Hello everyone, I hope you enjoyed yesterday's maths work. We're back to look at some more statistics, but this time we're going to look at a line graph, so not just the tables and the bar charts from yesterday. And we're going to start by looking at this chart, which as you can see the levels are already on the axes. So we have the day here down on the x-axis, and we have the ice cream sold on the y-axis. Overall this tells us the number of ice cream sold at the ice cream van. So let's get straight into it. We're going to think about these questions. First of all, when is there a sharp increase in sales of ice cream? Well, that's between Friday and Saturday. You can see the slope here is a lot higher. It goes from 100 to 225. That's an increase of 125. When is there a decrease? Well, overall, it tends to go up, apart from this bit, from Wednesday to Thursday. But if we were predicting, we could maybe say between Sunday and Monday, because you can see Monday is quite low and Saturday is quite high. We don't see Sunday. But if it stayed high, then it would probably go low if it went to Monday, and this was every week. Now here the x-axis, the horizontal axis, it shows the days, and that's discrete, meaning it's in day-long blocks, while the y-axis is continuous. That's why it goes up in a smooth line in between them. We can't find how much sold was after midday on Thursday, for example. That's the reason why sometimes these charts will be seen as bar charts instead of the line charts that you see here. But we can still use something like this to say, how many ice creams were sold on Tuesday? Well, let's find Tuesday. Pause the video and try this for yourself. We can see there's Tuesday, and line across goes to 125. And we can do it the other way as well. On what day were 75 ice creams sold? Try this yourself. And then this time we're going to want to put line through 75 and see, right, where does it come through? There's actually 2 points. There's this bit here, which is halfway between Monday and Tuesday, and this bit here, which is actually on Thursday. Remember, we can't find out what was sold halfway through a day, so in this case it's going to be Thursday. Now, it's your turn. On which day are more than 75 ice creams sold? I'll do that one with you, and then I'm going to want you to do the rest yourselves and try this. So, more than 75 here, I would want to draw the line along 75 and say, right, anytime it's over 75, so Monday is under 75, Thursday is exactly 75. So on Tuesday, Wednesday, on Friday, just because they sold 100, and on Saturday, they sold more than 75. And again, if we made a prediction, we could say Sunday, but we don't have the data to back it up. Now pause the video, try all the others, and don't forget to send these to me, as I'm not going to show you the answers in this video. Now, these are some other types of graph, and for this one, I'm going to need you to get a bouncy ball at home. It could be a tennis ball or an actual bouncy ball. You could even make your own out of rubber bands if you want. And I'm going to want you to throw it down so it bounces higher. If you don't have a bouncy ball at home, then I've put a YouTube link here that you'll be able to get and you can look at. I'll include this in the Purple Mash post. And once you've done that, I want you to think which of these graphs you think best represents what happens with the ball. Let's see. Well, it's this graph because when you throw it down, remember I said throw it so it bounced up higher than it started. You can see it started over here, and then you throw it down, and it bounced up higher than it started, and then over time bounces down until eventually it doesn't bounce. So have a go at these questions. Pause the video and have a think about it. How many seconds do you think the ball took to stop bouncing? Well, I think about 8 seconds. Obviously, it depends on the ball. The bounce of the ball, it might just do a lot of those small bounces at the end. Also, if it goes up higher, it might just take more time in the air. Depends on the ball you have. What do we think was duration of the highest bounce? I think a second, maybe a second and a half. I don't think it would go really high unless it was a really, really bouncy ball. You can get those really bouncy balls, but then in that case, I think it might have gone higher up this graph. And what would 0 mean for each variable? Well, if it was 0 centimeters, so it was down here on the y-axis, that means that it's on the floor. That's the point where it touches the floor. 0 seconds over here on the time, that means I haven't yet thrown it, so I haven't started throwing it. Now, with this information, I'm going to want you to do one more task here. I want you to look at this, and I want you to draw a graph that best represents this story. Clive's mum takes him to school. She has a chat with the school administrator before walking home quickly. Think about these. How can you show when Clive's mum isn't moving? And how can you show when Clive's mum is moving quickly? If you feel confident, pause the video. But if you need a bit of help, I'm going to give you some tips. If she isn't moving, the line is going to be flat. Time is going by, but she's not moving any closer to or further away from home. Whereas when she's moving quickly, the line is going to be steep. That means that they're covering a lot of distance in a very short time. So a quite shallow thing when they're walking to the car, for example, but then if they're going in the car, then it would be very steep as they drive off. Now, the final thing I want you to do is there's a task on Purple Mesh about a bike ride. I want you to give this one a go, try it, and email me your results. Good luck and let me know how you get on.